Oh, hello. Second. Oh, wait, I'm gonna say hello, Avani. All right, good to see you. Hello, good to see you. I'm gonna say hello to everybody else in this. Good afternoon, Melita. Good to hello, Cheska. Good to see you. Good to see you. Okay, now we're rolling. Hello, yeah. Good afternoon, Yavi. Good afternoon. Oh, here we go. Okay, now I can't go. Okay, I'm gonna get there. One sec. Here we go. Here we go. Yes, excellent. Wait, let me read the chat. Good. So, oh, and hello, Chris Chuffer. Good afternoon, Melita. Good afternoon, Yavi. Good afternoon, Hayu. Good afternoon, Matthew. Good afternoon, Giselle. One sec. Good afternoon, Amanda. Ha! Oh, and I did catch. Okay, regarding pizza. Regarding Felix. Uh, Thank you for asking. I did catch the very nice text from Chris about Felix at the end in the chat. I did see that after we were shutting down, and I appreciate it. Yes, he did. He just had a birthday this weekend, so we've been very involved. Yes, but thank you. Yes, I'll move on, and we're going to be I think this is that class that we always get interrupted. But well, we'll do something about that. I'll do something about that. But anyway, I appreciate the kind words and the concern. Okay. So here we are. Did I say hello to everybody? Oh, and hello, Melita. Oh, in video. Yes. Okay. Cheska, Christopher, Avani, video stars, video killed the radio star. And a new portal has been put up. Did I miss anybody? But I think I've said hello to everybody. Hello to everybody in the chat. Maybe I didn't say hello to Michelle. Hello, Michelle, who I feel like used to have an avatar, but maybe I'm wrong. And hello, Marilyn, if I didn't say. Okay. Hello, everybody. Hello. Say. Okay. Anyway, let's get going. Uh, wait, hear me, right? Did I check that? Because yes. Okay. Thank you, Melita. Okay. Okay. Hello, hello, Michelle. Excellent. Excellent. Okay. We're gonna get rolling. Logistical things as always. We're still in that stage. We're still in that stage where I'm not assigning any new sheets to you for a little while until we're in a continuous catch up with each other now. I've been getting texts and emails from people over the weekend, like, can I still turn in homework 4 or whatever? Like, yes. Until I say otherwise, you can still turn in anything. You could turn in a revision of homework 1. You could turn in homework 4, and I still owe you feedback. We're just rough drafting back and forth to each other until an exam or until I say otherwise. Which means, again, just another, because I know some people are hearing everything and some people are hearing some things. Another reminder: if you ever get a score on a homework that is less than perfect, if you get less than all the points, but then you don't see any feedback, that means I still owe you. It doesn't mean you should do anything. It means you shouldn't do anything. It means you shouldn't think you got anything wrong or anything. It means you've already gotten a bunch of points from me, and I still have to look at it more closely. If you get anything but a perfect score, but you don't have feedback to justify it, it means don't do it. Just keep moving on. It means you've done enough that you're on top of things, and more is to come from me. I'm just clarifying. I think most of you get that at this point, but I'm just clarifying because whatever. Also, so there's no new homework until there is. But one thing I think what was clear in this class that I asked you to watch the video from the other class last Monday. I think you all did that. I should have given points for it somehow. I sort of forgot to do that. I'll do that next time, or I'll retro do it somehow. A new portal opened up. Excuse me. A new portal opened up for anytime anybody corrects me, particularly on physics. Maybe I didn't make that clear, but especially if you catch a physics mistake or something that you think might be a mistake, please do correct it, and you get points for that. Maybe whether you were right or wrong, or whatever. So that portal opened up. Wait, there's one more thing in the chat. So what we're gonna do in a minute. This is all. Oh yeah. Oh yes. Okay. Sorry. Something in the chat. It reminds me of two things. Yeah. So someone's asking in the direct chat just to make sure for like a I'm paraphrasing, but it says for a regular game turn, like turn 1, turn 2, etc. Can you send in a screenshot of you with your camera on for a regular game turn? Yes, absolutely. I see why that's a question. Yes, you can. And then you can also double dip that same screenshot into the video portal. Yes. Like, yes. Yes. Any way that you participate at all counts as a regular game turn, and that including showing video or showing an avatar or saying hello in the chat or anything. And then correct. And then if you happen to have participated in sort of a specialized or designated way, such as showing video, then you can also double dip the exact same thing in any other portal that applies. That is correct. And that also is around, and there's something else in the chat. Okay, so now Melita's question. Yeah, I think this is an important question. So with the game turns, they are supposed to be every day. The regular 5-point game turns, they are a daily check-in, like moment of reflection. Like, did I do anything in class today? Like, that's their purpose. It's like, so you have a moment where you can ask yourself, like, did I even attend class today? Did I get anything out of class today? And again, even saying hello in the chat counts. Whether it should or shouldn't, it does. So with the game turns, they are supposed to be every day. They are like a daily check-in. If you do it the next day, you get 4 points instead of 5, whatever that difference makes. Then after the next day, just let it go. The game turns are supposed to be every day. That still doesn't fully answer Melita's question. Wait, okay. So to Chris's question, on the game turns, because they are meant to be a daily check-in. They are meant to keep you and me sort of in like regular contact. If that game turn is a day late or after Midnight River, you get 4 points instead of 5. So that it's a notation, it's a acknowledgement that I'd really rather that be on the right day. That one thing, I'd rather it be on the right day because it's a daily check-in. So if the next day you get 4 points rather than 5. But after that, just let it go because it gets very confusing. It's what I won't take is like at the end of semester, like 40 game turns. That doesn't make any sense. That defeats the purpose. So with the daily game turns, like turn 1, turn 2, turn 3, yes, they're supposed to be. That's the bizarrely, other than exams, that is the only thing that I'm sort of strict about timing. Also because they're meant to be really fast. So it shouldn't really be, it's more just about remembering to do it than having to do anything hard. So on those, yes, it's supposed to be on the time, on the day. If it's 1 day late, because it was like after midnight, you get 4 points instead of 5, which is not that big of a deal. But after that, let it go. Now that's on the game. So hopefully that answers, okay, hopefully that answers Chris's question. But now the other part of Melita's question, maybe the more important part, and this also relates to another thing that's now in the direct chat. With all of the other things, all of the other portals that are due in December in theory, that can be done at any time in the semester, such as showing video, possibly the most vivid example of them. With the ones like showing video, okay, those you can submit and resubmit and re-upload on a regular basis. And you should, if you're showing video like every day, then what you should do is every day at the end of the day, yes, upload a screenshot of you showing video or whatever the example is. Like on that, like today, just to use an example, who's one asking? Like Melita's showing video. What she should do is she should submit to the video portal today. She should. And then on Wednesday, if she's doing it again, she should do that thing of unsubmit and re-upload a new video, and then hit turn it in. And she should not take down the old one. And ideally, all these screenshots or whatever are all time stamped or whatever. And I'm just using her as an example, and I'm just using video as an example. But with those portals that are all optional and are all about like different ways, or let me take a completely different example too. Those of you who are quieter, but take a lot of notes, There's a video, I mean, there's a portal for taking notes where absolutely, if you take good notes, especially you write things down that I don't write down, every day that you do that, you can and should submit a new example of your notes. You should again, it only takes a couple of minutes, but it's meant as like a daily reflection or whatever. And you will, if you just keep it organized and like every day that you take notes, you put up a new copy of your notes, then even if I fall behind with the points, whenever I open up the portal and I see that you've got 3 screenshots of notes from 3 separate clear class days, right? Then I will give you 3 times 7 points or whatever it is. So yes, you really do want to be upload whatever way you participate, whether it's taking notes quietly or uploading screenshot images into the chat or showing video, like whatever is your jam. It really is to your benefit to regularly like submit for those points and make it so that I can follow what's going on as we go and keep giving you those points. The thing you don't want to do, just to wrap this up, the thing you don't want to do is right at the end of the semester, all of a sudden go back and start scrambling for a bunch of different screenshots or a bunch of things and then upload them all at the same time, because that it's very hard for you to document then when's from what and what's from when. And it's very hard for me to deal with. And it sort of also defeats the purpose. So yes, those of you who are doing things multiply, like regularly, like frequently showing video or frequently taking notes, you should be frequently, to your own benefit. None of this is mandatory. All of this is optional, which is, it's all self-monitored, but every time you upload, you get points. So yes, I hope I'm sort of answering the question. It also leads me to realize of these questions, yeah, for some reason last Wednesday, I just totally beefed it. I don't know how. I just totally forgot to give you the game turn for last Wednesday. Normally, that's not a mistake I make. So then I just retro put it up today. Now that's my bad. That's on me. So anybody who does game turn 5 from last Wednesday, if you do it tonight or tomorrow, I'm not going to take off points for that. Like that's my fault, not yours. So if you just do it so we can get back on the path and stay in order with ourselves, you'll get full points for that. That's the exception because I made that mistake and I apologize. I don't know. All right. So hopefully this is all answering. But again, please, if any of this is not clear, please send me a text or an email and I'll try to make it more clear. Or if you want to have a quick phone call, I'll try to make it more clear. It's all of it is optional. And that's why I don't enforce it. Like, that's why I keep talking about in class. I'm not going to look at and start grabbing people who don't submit for points. None of you has to submit for any of these points. But the people that do submit for a lot of points and make a habit out of it really end up getting a lot of points, and it makes a huge difference in their grade. So and it's true for Physics 204 as well. The other reason I'm willing to keep answering these questions or keep talking about it is it's just enough of an unusual system, but it will be with you for 2 semesters. So it is worth understanding. It really helps your grade. Again, if you happen to be, it's meant to gamify all this too for the sake of Zoom. So if you happen to be the kind of person that, I don't know, like maybe spent any time during COVID playing Animal Crossing on the Nintendo Switch, for example, or something, then think of all of this as Nook Miles. It's all Nook Miles. That's all it is. If that means nothing to you, then that's fine too. Okay. I'm going to go, but please text me if you don't understand it, because that's all. Okay. All right. So hopefully that made sense. Okay. I'm just looking back. So maybe the people that did ask me the direct chat questions could maybe let me know if I'm answering them, because that also, you would get points for doing that. But other than that, I'm going to go on. Yeah. So what I'm going to do now, because in theory, thank you. All right. And so the direct chat person who just said, yes, I did, thank you very much. I'm not saying any names, but that direct chat person who asked questions, I just hope that direct chat person also knows that now he or she literally can go to that portal that says closing a conversational path or something like that. She can go to that portal. He can literally screenshot this conversation that just happened, and she or he can get points for the fact that I now know I can move on. I just hope that's clear to everybody. So I am going to move on. Well, I'm moving on to homework 4. Yes. I'm going to get straight to it. To homework 4. Because in theory, you all watched the video from the other class where I built up the equations that are going to help for homework 4, right? And you were the class that we went over homework 2 in great detail with this class. So thank you for that. So I'm going to go over homework, and there's still homework 3. This is why I'm not assigning any new homework for a little while. I have not forgotten about homework 3. We will eventually circle back. So I apologize that it's like out of order, but I'm trying to stay with the momentum because I've been getting a lot of emails and texts over the weekend. So I feel like what most people are like focusing on right now and possibly anxious about is homework 4. So that's what I'm focusing on. And homework 3 is conceptual anyway. It's like slightly off to the side. So we will go back to that before there's ever a homework, before we deal with a homework 5. But homework 4 here on the screen now. We're going to start with part 1. That's called a very quick review. I'm writing in brown here. I'm just going to alert you. A lot of times now that I've gone over the 5-step method in detail with you, now that you've mostly gotten at least one big set of feedback on it, most of you on one homework, a lot of times now when I'm trying to catch up with myself or trying to go faster, I'm not always going to write out the whole 5-step method in my solutions. Often I'm going to do partial answers and partial things where I think people need help. So you just have to understand, if this were an exam, if we had an exam that looked anything like these problems, you would have to submit more than what I'm going to be doing in these notes sometimes. Like I don't know if that's clear enough, but you're still responsible for the 5-step method, but I'm not always going to do every single step when I do quick exercises, because I expect you to, but I'm not. I don't know what to say, but I hope that's clear. But the one note I have to say before I go any further, it says here on the board, for the last problem on homework 2, okay, homework 2, you guys, this class, and I went over the second to last problem. It was intense. There might still be questions about it. I realize now that's where we left off. If you have questions about that hill figure problem, please do feel free to ask them. That was the problem. You go up at 40 miles per hour or some units, you come down at 60 miles per hour. The question was, what was the average for the whole thing? We found that the average was not 50. That's like a big important revelation. The average was not 50. The average was 48. So that's interesting. The way to find out if you really understood all of that, one good way and there will be something like that on the first exam for sure, something. The way to know if you really understood all of that is to go back and look at the very last problem on the sheet on that homework 2. The very last problem on homework 2 was the same exact concept. It was one touch harder. It was, you were given different information and solving for different information, but it was literally the same concept and the same equations and all that. So on the last problem of homework 2, when you first did it, many of you might have gotten an answer such as 120 miles per hour or something like that. Like if I remember, yeah, a common answer for the last question on homework 2 was 120 miles per hour. If you look back at all your notes and what we discussed for the hill figure problem, you'll realize that answer is not correct for the exact same reason that 50 wasn't correct in the hill figure problem. That is to say, average speed is distance over time. It's not average of the speeds. That's the lesson of that homework. So I'm telling you that if you want to really see if you really get it, redo the last problem and you will find that the answer to the last problem, I'm telling you the answer. And then you should like work it on your own. And if you have issues, you should bring them up in class. It is your class. And I won't be ashamed, or I mean, I won't shame you, and you shouldn't be ashamed. I think the answer to the very last problem on homework 2, the Grandma Grimm problem, I think the answer is infinity, meaning there's no, which is an answer, by the way. That doesn't mean it's an illegal question. It doesn't mean the question has an error. It means there is no finite speed at which Little Red Riding Hood could go on the way back in order to make 80 miles per hour be the average speed for the whole round trip. She would have to go at an infinite speed. She would have to get to the other location in 0 time, in an instant, in order to accomplish the task of the problem. I'm telling you that's the answer. I'm not telling you that's easy. I'm not telling you that's obvious. In fact, I'm saying it's, in fact, one touch harder to see than even the last problem. But I am telling you it's the answer. And what you should do is make sure you're okay with that in your own time, based on the lecture we did last time. And if you're not, you should let me know. We could talk about it. But it is a good practice to see if you understood the last problem. Anyway, so the answer to the Grandma Grimm problem, the last problem on homework 2, is she would have to go at infinite speed in order to accomplish the task of the problem. And sure, I'm sure she's not physically capable of doing that, but that's the mathematical answer to the question. Okay, that said, I'm going to move on. I'm sure I'm going to move on 20 minutes later. Okay, let me just change the view on the screen. We are going to go to homework 4, Roman numeral 1, a very quick review. And here it is. Okay. So I did do step 1. I drew a diagram because I always should, and because it asked me to. So I put Berlin up here, and so this is the problem, and hopefully you have it in front of you. Stop me if you don't. This is the problem where Berlin is 700 miles north of Rome, and there's an airplane or something. Someone travels from Berlin to Rome in like 4 hours or something like that. And then it asks you about, and it's just supposed to be a warm up about vocabulary, but I actually got a couple of emails and texts about this. There was a little confusion from some students. So here's the quick deal. You got to draw a diagram. You always have to draw a diagram, even if you're not given one, maybe especially if you're not given one. And part of the purpose of a diagram, remember, is to label all constants and variables that are going to be used in your math, but also to label all coordinate systems, all coordinate axes, all directions, to label, to put pluses and minuses on whatever directions whatever different directions exist on the different axes of your coordinate system. You have to choose a reference frame, in other words, for every problem that you solve in physics. And that's really the secret purpose of homework 3, is to get that idea across. Homework. So in my picture, I've labeled, okay, here's north, Berlin. Berlin is to the north, Rome is to the south. And then I've gone an extra step, even though the problem didn't mention anything about this. I've gone an extra step to say, all right, since now we're going to be numerical, now we're going to be mathematical, now we're going to be scientists, I'm going to call north positive, and I'm going to call south negative. Now that is a choice. You might make a different choice. You could make a different choice. You could call north negative if you want. I'm not kidding. You could call north negative and you can call south positive. But what you can't do is make no choice at all. We have to make a choice about what's positive and what's negative, and we have to announce that choice in our diagram. That's part of the purpose of diagram. So I have and notice the problem didn't say anything about positive and negative. That's what we're getting used to. The problem didn't give me a picture. The problem didn't say anything about positive and negative, but it's a physics problem. So I'm hereby declaring that north is positive, south is negative. So now it asks me about distance, displacement, average speed, and average velocity. So I write my distance that I traveled definitely was 700 miles. Distance is like an absolute value kind of thing. And again, please notice here, I'm skipping steps. I'm not writing down step 2. I'm not writing down step 3. You need to. You would lose points if you did not exam, but I'm trying to sort of move faster and faster in the course now. So I'm just writing the answer to A is that the distance equals 700 miles. Boom. The answer to B, the displacement, according to my coordinate system, is negative 700 miles, right? And those answers slightly differ. Like one has a negative sign. Let me say again, could you have made a different choice? Could you have flipped your coordinate system so that, in fact, going south is called positive? Yes, you could have. And then would positive 700 be the correct answer for B? Yes, it would if you did that. But 2 things. One, you'd still have to say positive somehow. You still have to make direction explicit. And number 2, like I would give full credit for the answer positive 700 miles for answer B. If anybody in the Zoom room wrote down positive 700 for B, that's full credit. That's fine. That's yay. As long as their diagram made it clear that that's how they're looking at the world, then fine. In fact, I might even be impressed at how clever that is. In fact, it is kind of clever because we want as few minus signs as possible. So, okay, I'm going to go on unless if there's a question, definitely raise your electronic hand or whatever, or well, you know what to do. All right, so then the average speed is 700, is distance over the time, 700 miles over 4 hours, so 175 miles per hour. And then I go to the next page. Hold on, where's my, okay. And it's negative 700 miles over 4 hours is the displacement. Notice again, whenever there's like displacement or velocity, I tend to go to symbolic equations. That's what we're getting used to. And with the others, I tend to be in English, but that's just a choice. But so we get, oh, I should have circled, sorry. I know why sorry. This thing is circled for other reasons. I don't mean to circle that, but okay. And then so then the average velocity is negative 175 miles per hour. Okay, so that's the end of that. Okay, then we go to the next instantaneous velocity. Now, very intentionally, like now, hopefully you watched the other video where I really tried to explain what we mean by instantaneous velocity. But the main thing here is we're now talking about a new concept called instantaneous velocity. When this homework was assigned, I hadn't seen a whole video on this or anything. The assumption is that this is figure outable from definitions and from what we already know. All I'm saying right here is velocity, instantaneous velocity means velocity at an instant, right? I'm saying it as opposed to average velocity. The one thing I'm trying to make clear right now, introducing in this question, is we've been talking about velocity on average over an interval between 2 points. We have a definition for the average velocity between 2 points in time. Now this question is suddenly introducing or asking about velocity at an instant in time. Now, what does it mean? It means just that, how fast you're going at an instant of time. And yes, I talk in more detail about that in the other video, but just in terms of English words, we're now talking about what the police officer is concerned with if the police officer pulls you over, right? When the police officer pulls you over and says, do you know how fast you were just going right then? Right? We know, we know, I think we know, or I hope we think that if a police officer pulls you over and says, do you know how fast you were going right there? You don't say, well, I've been in my car for 3 hours, and because I spent 2 hours of that 3 hours at a rest stop, just sitting still, the total amount of distance or displacement that I've covered for those whole 3 hours was only 30 miles because like I was sitting in a rest stop for like most of it. So I've traveled 30 miles in 3 hours. So on average, I'm going 10 miles per hour. So I don't know what the problem is, officer. Like that would be a hideously inappropriate thing to say, right? I mean, first of all, it's obnoxious. But second of all, like that is not, that's all true, by the way. All of that could be true. That you could have covered a total displacement of 30 miles and you could have done it in a total time of 3 hours. And therefore your average velocity is only 10 miles per hour. And that's because you were sitting in a rest stop for most of it. That could all be true. But that is not what the police officer is concerned with. The police officer is like, yeah, you were sitting in a rest stop maybe for 3 hours. I don't care. I wasn't down, whatever. But now you made up the time. You more than made up for your time because just now when you passed a school, right now you raced past our laser detector thing, radar, right in front of the school. You just passed the school going like breakneck speeds. And I don't care what you were doing for 3 hours on average. I care about what you were doing at the instant you went past a bunch of children, right? Like that's what we're talking about here. How fast are you going right now at a point in time? Now, the point is this. At the time that you were assigned this homework, you didn't have any formulas or equations for that. I know that. That's on purpose. And even if you watch the other video, we started talking about equation-y ways and mathematical ways of talking about that. But I'm not even sure that we know how to use those calculus derivatives in order to solve it. We're just saying saying what we're talking about here is velocity at an instant. So is that something that we can figure out even without complicated calculus or something like that? Well, the answer is yes. Depending on, let's break down the concept. Depending on the situation, instantaneous velocity is figure outable through logic and thought, and that's where the equations get built from, not the other way around. We build equations from logic that make sense, and then we like to use the equations to save time. But we're not at bay just because we don't have a specific equation. We're like, so here's the situation here. The facts that are given. I guess here I am sort of doing the step method because this problem's a little bit harder. So I'm doing the step. Here's step one. Like a weird diagram right here. And here's the facts, right? And I want you to, and then I write the facts down, right? This is all step one. What facts did I, so I wrote my little weird diagram. I labeled that to the right is positive, and I labeled, and to the left is negative. It's a very squeezed diagram, but also notice that I labeled, if to the right is positive and to the left is negative, that where the car started its journey, I'm declaring to be called x equals 0. In fact, let's even equals 0. Remember I said last week, you can't always assume that x naught is always 0. It isn't always 0, such as the first homework of the year, the number line, the instructor starts at a position called +4, right? X naught just means wherever you were when t equals 0. But like we're saying above, it's our job as physicists to make choices and choose coordinate systems and designate directions and designate origins that will make our life as convenient as possible. So when possible, if I'm not told otherwise, I like to declare, okay, the initial position of this car, where we started paying attention, I'm going to call that 0. And that way, whenever I write, this is why I circled this before. So whenever I write the one equation that I use all the time, whenever I write this down, in a situation like this, if I'm declaring that x naught is 0, I'll be able to cross that out and make the numerator even easier, right? So whenever I can do that, I do that. All right, so I'm calling x naught to be 0. I'm saying the car was traveling for 30 minutes. That's what was given in the problem. And x is 40 miles. That was given in the problem. And then I'm also writing down this very important fact. And again, this is to emphasize that don't think that facts are only important only if they're written in mathematical terms. The problem also said in English that the velocity remains constant of this car. So I write that down in symbolic terms. I write v equals v naught, like this is what I'm talking about right here, right? The problem said that in English. It says whatever the velocity is at any given moment is the same as whatever it was at the beginning. I mean, that's the meaning of the term constant, right? So the way physicists will say that something like velocity is constant is they'll write v equals v naught. That means the value doesn't change. That's a very important fact for this problem. Okay, so I wrote it down. I wrote all these things down. Okay, that's my setup for the problem. Then I go, again, stop me at any time if you want me to go back, of course. Step 2, so what's the question? The question is, at t equals the 18th minute and the 42nd second, what is v? What is instantaneous v? And again, I'm emphasizing, like v, we're now asking about v at an instant. It is not the same, does not mean the same thing as v on average. Really, that's what I'm trying to emphasize right now. We're now talking about velocity at an instant. On the one hand, I want everybody to see that's not the same thing as average velocity. On the other hand, I don't want you to be intimidated. Like, do we have an equation for it that helps us solve for it yet? Like, sort of not really, kind of no, kind of yes, maybe. I don't know. All I know is that's what I'm being asked for. I'm being asked for what is velocity at an instant, and I'm being asked this maybe very intimidating, sort of obscure sounding thing. They're literally asking me, what is the velocity at the instant that the clock goes, 18 minutes, 42 seconds? That could sound very like, whoa, how am I possibly supposed to know? I don't know. I mean, I'm sure some of you do, but I don't know yet. But what I'm going to do, I don't know how to get the answer yet. I'm going to proceed with the 5-step method. Instead of trying to leap to exactly what the answer is or how to get it, which again, I do know that some of you got in your head, and I am impressed, and I never mean to dismiss that. But I'm also talking to those of you who didn't see this in your head, or those of you who find this to be an intimidating or confusing question. And I know from the emails and texts that I get that there are those of you, and I would have been one of you. I'm the guy that does not see this immediately. Trust me, I'm the guy that has to think this through. Luckily, I like thinking it through, so here we are. But okay, so we're asking for V without a bar over it. So what do we do if questions are just starting to get hard now? We go to step 3 GDP and we write down something that we know is true. The one thing in this class, like really the one thing in this class that we know so far to always be true, because it's a definition, it's always true, it's a triple equal sign. We know that average velocity is displacement per time. Now, please note, all of you, some of you did not get this right. Some of you gave up on this. I know. Some of you got it right for the right reasons. Some of you got this question right for the wrong reasons. So everybody needs to tune in to make sure they got, and it's like by a coincidence, that won't always work out in their favor. So let's be careful now. Please note, I'm writing down step 3, V bar, triple equal sign, displacement over time. I'm writing it down because it's true. It's not the thing I'm looking for yet. Please, everybody note. The question didn't ask for V bar. The question asked for V without a bar. But I'm writing down V bar because it's something I know to be true. So even if I don't quite know what to do yet, at least I'm advancing. I'm making progress. I'm writing something that's true. So I'm going to get points for it. And hopefully, as I write more things down, I'll figure out something to do with it. But it is not the final stage. It is stage 3. Step 3, average velocity equals displacement over time. Okay, so I move to step 4 now. Okay, so I start working out the things I do know. I know that x minus x naught equals 40 miles. I particularly know that because I declared x naught to be 0, right? So x, how far is that? 40 miles. I know that t equals 30 minutes. Just for a little bit of, you don't have to do this, but I converted that. I've changed that to a half hour just because miles per hour, meters per second are the ideal scientific thing. But miles per hour, at least, is like a natural, like common American unit that we can all relate to. Miles per minute, like it's kind of hard to relate to. So I wrote down in miles per hour, and I wrote that V bar equals 80 miles per hour. Now let's pause for a second. Notice I haven't circled anything yet. I haven't turned the page yet. I'm in step 4 here. I just want to make this absolutely clear that step 4 is saying that average velocity, the average velocity of this car, or whatever, this car, is 80 miles per hour. That's my step 4. Now, the reason I can't just circle that and call it my answer. Maybe my answer looks a lot like that, maybe, but I can't just circle that. And right now I'm mostly talking to the people that maybe got this answer right, but maybe for the wrong reasons. So I'm just going to be clear. This is not my answer yet. And the reason it's correct, it's true. Average velocity does equal 80 miles per hour. But please remember, the question didn't ask me for average velocity. The question is a police officer. The question's asking, I just passed a radar at the 18th minute, 42nd second. And the police is saying, how fast was I going right then? That's not what this says. This says on average, I was going 80. Well, if I just walk up to you and say, you took a lot of exams in this class and your average is a 94, what did you get on the 3rd exam? You can't answer that just based on that information alone, right? Let me say that again, just make clear. Or you do it to me. Like if I took a lot of exams in this class, and I know I took a lot of exams in this class, and I know my average is a 94. If someone just walks up to me and says, so what did you get on the 3rd test? I can't figure that out from that information. I might have gotten a 96 and I might have gotten a 92 on another test, and the average that's a night, right? So all I know right now is that my average is 80. Average is 80 miles per hour. But it says, but the question also states this other fact that I haven't used yet. There's one other fact that I have not used yet. The other fact is that V equals V naught, which means wherever we are in the journey, the velocity is the same as it originally was. That means wherever we are in the journey, where in this case, like because the velocity is constant, that means the velocity always has to be whatever the average is. In this case, right? Notice the side bracket. I'm not, when it comes to triple equal signs, I'm saying V does not triple equal V bar. They do not mean the same thing. They are often different numbers. Just like your average in a class could be 95, but that doesn't mean like on any given test you necessarily got 95. However, if you know for a fact that your numbers are never changing, well, then yes, any given number is the average, right? If I went up to you and said, your average in the class is a 94, excuse me, a 98. I say your average in the class is a 98, and you took a whole bunch of exams, but you got the exact same score on every single exam. Then what did you get on the third exam? The answer is 98, right? Like that's what this is saying. So this is another one of my annoying things. Hopefully I'll get less annoying soon. Or maybe I won't. But like I'm kind of saying, okay, so in this case, because the velocity is constant, then in this case, the instantaneous velocity works out to be double equal sign the same thing as the average velocity. In this case, the answer is that the instantaneous velocity is 80 miles per hour. So it's a little, so I'm saying 80 is right, but I hope you understand that 80 is right only because of that extra special fact it gave, which said that the velocity was constant. If it hadn't said that the velocity was constant, you could not assume this. And just because you divide, so I'm also trying to say to everybody, if you want, the lesson here is, if you want instantaneous velocity, you can't just divide displacement by time. That does not get you how fast you're going at a moment. If you want instantaneous velocity, you have to look at context. If you want to know how fast something's going at a point in time, somehow you need to know more about the various points in time from which we extracted that one point. If things are simple enough, we don't need calculus to do that. We can just stand back and use logic. Like, oh, in this case, all the velocities were the same, so the velocity at any moment was the average velocity. In the next set of problems we're going to, it won't be that simple. In the next set of problems we're going to, it won't be that all the velocities are the same. It's that they'll all be different, but they'll all be changing in the same way. Like the next level we're going to with this sheet, what this is trying to set you up for is acceleration. Constant acceleration means that the velocities are changing, but they're changing in a predictable, patterned way. So when there's a constant acceleration, we have some sort of pattern or rule where we could say, well, he got from here to here in this amount of time. It's changing, but he was always changing in a patterned way called acceleration. So if I want to know what the velocity is at exactly the 18th moment, 42nd second, I could go backwards and infer, well, I'll just like, yeah, like the next level is to say, what if I want to know the velocity in a situation where things are changing? Well, if they're changing in a constant way called acceleration, then there's another, then in order to get velocity at a random moment, you could rearrange this and say the velocity at any random moment is the acceleration times the time plus the initial velocity, right? Yeah, I'm saying, is that two more equations that you should memorize? No. What I'm trying to say is a larger concept is we can always get instantaneous velocity as long as we know the larger context that it's buried in. If the context is simple enough, there's a simple equation to get it. If the context gets more complicated, calculus is the art of embracing these contexts. The whole point of the calculus is it's a way of standing back and saying, you know, what's happening at one moment has to do with the larger, what's happening at one frame is totally inferable as long as you watch the larger movie. Calculus is a way of saying in one actual photograph, there's never motion, but in one frame that is part of some larger pattern of frames called a movie, there is always motion. And we can always figure out the motion in a frame if we look at the larger movie. put one last final way, in more strict calculus terms, what we're ultimately saying here is there's one dot never has a slope. There's no meaning to saying that a dot has a slope, but there's always meaning in saying that a curve, no matter how complicated, always can have a slope at any of its individual constituent dots. The slope of a curve at a point is a derivative. It's equivalent to the motion of something, the motion captured by a movie at a certain frame. That's what we're talking about here. All right, so I'm going to move on to the next question, which is average acceleration, starting to practice the equation a little bit more. So in the next question, we have this car. I'm just looking at the time. Oh, we have time. Okay. In the next question, we have a car that starts at 0 miles per hour. Sorry. And then gets up to a final instant. Excuse me. Let me back up for a second. Its initial velocity is 0 miles per hour, V naught, right? Now notice V naught, people get confused about this. Let me just address this. V naught means initial velocity, right? Just like X naught is initial position. V naught means velocity at the moment t equals 0, right? That's what it means. Now it starts to sound to some people like we have a million different types of velocities going on. Like there's initial velocity, there's final velocity, there's instantaneous velocity, there's average velocity. Let me say one thing. No, there's really two types. There's average, which has a bar over it, and there's instantaneous, which has no bar. Anything that doesn't have a bar is some kind of instantaneous velocity. But if it's V naught, so V naught and V, they're both instantaneous velocities. It's just V naught is the instantaneous velocity at an early instant, and V with nothing next to it, or V sub F or V sub 2 or something, is instantaneous velocity at a later instant. Okay, they're both instantaneous velocities. So what's given here is that the initial, the earlier instantaneous velocity is 0 miles per hour. And then of this Toyota, this 1975 Toyota Corolla, whatever. And then the final velocity is 60 miles per hour, right? Those are given facts. Again, I'm in problem 3 on homework 4. Stop me if you don't know where I am. And then we're told that the car takes 2 minutes to get from one instantaneous velocity to the other. And we're asked to compute what is its acceleration. Okay, this is like a straightforward exercise or practice in the concept of average acceleration. So the definition of average acceleration is change in velocity per time. The sheet phrased it slightly differently. The sheet said like delta V over delta T. You want to get a little bit flexible in your mind about these different notations. You know from math that delta means difference in. Okay. Wait, something's in the chat. That's good. I'm just going to finish the sentence and get the chat. But just for the record, delta means difference between, well, technically, delta means small but finite difference between two values of a variable. So when it said delta V over delta T in the sheet, you could write that down as V minus V naught over T minus T naught. And then remember, T naught is always equal to 0. So I cross it off and I have V minus V naught over T. I'm going to get the chat thing. I totally am. I really want to reinforce. Soon I'm going to pause, whether today or tomorrow, probably tomorrow, Wednesday. I'm going to pause and just like stop and write down all the equations I think we have so far, because now we're starting to build equations, right? And maybe now it's starting to get a little jumbly or confusing for people. We don't really have as many as it seems. We basically have 5. But what I want you to see is a strong parallel and analogy between the equations. We have V bar equals X minus X naught over T, and we have A bar equals V minus V naught over T. They're very parallel in structure. I'll write them down again for you soon, but just notice on the left side, there's bars. On the right side, there's no bars. Average velocity is change in position per time. Average acceleration is change in velocity per time. Acceleration is to acceleration is to velocity as velocity is to position. It's like a Miller's analogy or whatever. The more you can let that sink in, the better off we all are. It's not a coincidence that those two equations look so similar, but they're similar, not identical. You want to see the relationship between the two of them, but you don't want to think that they're the same thing. Okay, I'm going to pause. But this is the equation we're going to use. The equation at the bottom is what I'm going to use in a minute to solve this problem. But first, I totally know someone's been waiting very patiently in the chat. Hang on one second. And maybe it's private. Yes, it's okay. Oh, great question in the chat. Okay, I'm sorry. I'm wondering if I should even write down the answer to this or just say it. I'm going to write it down. Great question in the chat. Hold on. So sidebar, really important. And okay, so the question in the chat, I'm not going to say the person's name, obviously, but question in the chat, but I am going to read it verbatim because it's a perfect. It says, I know you have said this a few times, but can you please explain triple versus double equal sign again quickly? Because I'm still confused. The answer is yes. I'm going to do it right now on paper. And I want to say to all of you, really, this is a great question. And it takes guts to ask a question like this. I totally understand why it was asked privately, but I want you all to know publicly, like, especially these kind of, especially, we're in September. It's September. Of course, one of two physics courses. Like, if I've said something a few times at this point, no, this is praise, what I'm about to give. I'm so serious. If anybody's noticed that I've said anything a couple of times at this point, I'm so glad that someone has the guts to, instead of saying to themselves, well, he said it a few times, so I guess I'm supposed to get it now. So it would be kind of obnoxious if I made him say it again, or it would be embarrassing or whatever. No, at this stage, if I've said something a number of times, it means I'm really trying to drill it in. Like, it's really important for the next 2 semesters. And I know from 30 years of experience that it actually is tricky and worth saying a number of times. So I'm thrilled. I'm sorry, I'm going to drag this out. It's September. This is the time for people to say, whoa, wait, I know you said it a million times, but apparently it matters. So can you stop for a second and really let it land for me? Like, yes, anything I've said a number of times at this point, I'm happy to say a number of more times. There'll be a point where I don't want to do that anymore, and I'll make it clear. We're not at that point yet. And there could not be a better example. Like, I'm going to be using triple equal signs and doubles till the cows come home. So I am super glad that someone's had the, and whoever asked this, I promise you, there's 3 other people that also know that they need to know, but didn't ask. And there's like 4 other people that need to know and don't even know that they need to know. For real. So here it is. So please, anything like this, please take a cue. If you think I'm talking too much right now, making a big deal, the reason I'm doing it is all of you who still don't understand what I mean by displacement or something, it's not too late to ask. It will be at some point, maybe, or my attitude might shift slightly. But at that point, still, I would just say, then it won't be too late to text me or something like that. Like, you get my point. Please, we're here not to cover. We're here to uncover and discover, if you know what I mean. So, because we will cover the material. It's not an issue. So, okay. So, but here's the answer. Sorry. I'm just really happy. Okay. Here's the answer. So triple equal sign means well, and I'll do the other one now. Hold on. Well, I'll do the other one next page. But so triple equal sign means equal by definition, or by declaration, or by dictionary, by human choice. Triple equal sign is a strong, it's an absolute equality. If it ever means anything at all, it always means something. If it's ever equal by a triple equal sign, then it's always equal. So for example, when we say a square equals a 4-sided figure, with 4 of the same angles and 4 of the same sides, blah, blah, all these details. But if I say that a square is equal, that's the word, or fine, or that is an example, but physics example. If I say average velocity, triple equal sign, displacement over time, what I'm really trying to say is that average velocity is just a word that we came up with to stand for the equivalent, the shorthand, for the longer bunch of words, displacement divided by time. I'm literally saying that we made the choice, that we decided that the quantity, displacement divided by time, is so important, or the ratio, displacement divided by time, is so important in the study of physics that we don't want to have to drag it out and say it out every single time. So we made a word for it called average velocity. And then we made a symbol for that called V with a bar over it. And literally, it's a language choice that we're making. So if average velocity ever equals displacement over time, it always does. It's not a discovery that we made in the lab, and it's not based on certain conditions, and it's not an approximation, right? It's the strongest type of equality there is, and it means it's a declaration. So it actually can't. If you're ever thinking like, why is it true? In a way, and you get confused because you're like, but I don't know why it's true, and I like to know why things are true. I like to know why things are true too. But anything that has a triple equal sign, the why, the reason is because we decided. It's like that simple. So we don't want to drive our brains crazy thinking like, was there an experiment in 1799 that like I was supposed to learn about in 7th grade that I forgot? Like, no. And also what that means is, if you understand it at all, just as a definition, it means that it will never be undiscovered. It's literally like squares are four-sided figures. If I say to you, hey, I just went to Pennsylvania, and they have this great museum in Philadelphia where they have a three-sided square. I saw this awesome three-sided square in a museum in Philadelphia. You could say to me, you are crazy, Averbound. Like, you literally could say to me, put down the crack pipe. And then if I say to you, that's rude, but whatever. But if I say to you, well, wait, have you ever been to Pennsylvania? Have you ever been to Pennsylvania? And you're like, well, no, I've never been to Pennsylvania. And then I'm like, well, how do you know? Blah, 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 blah. Well, okay, ASA, good, fine, right. So ASA, okay. So same thing. If I'm like, have you ever been to Philadelphia? Then how do you know they don't have a four-sided triangle? Or Amanda would be, and hopefully other people would be like, I don't have to freaking go to Philadelphia to know. Right. No, it's a good geometry reference, yes. But that's the deal with geometry. It's like based on definitions, right? Okay, and what Christopher's saying, so I won't dwell on this anymore, but I am saying in physics, we make that distinction. Sometimes things are equal in that way, and we want to really rely, whenever we can find equalities like that, we rely on them hard. Like, they are rigid, and we don't get into a whole discussion about it. It is what it is, right? They're like super reliable that way. But as opposed to, and that's what average velocity is. That's why we're starting this semester. I mean, it's a really dry way to start. I know it's boring and sort of like annoying, but we start all this physics with definitions because we're saying, like, we don't want you to have to take anything on faith. We don't want you to have to like believe us that if you had been there in 1799 and happened to have had a cloud chamber or whatever, you would see what we're talking about. No, we're just like, let's establish some terms. Let's just lay down some rules of how we use language and then see how far that takes us. And that's what we're doing. We're okay. But the other thing is equal. Hello, sorry. The other thing is double equal sign means equal by discovery, circumstance, or inference. Especially mean like mathematical analysis. Okay. No, now of course I'm a big believer in ninth grade music. Oh, wow. Okay, Amanda's thing. All right, I'll get that. Okay, Amanda's question is great, and Christopher's affirmation of Amanda's question is great. Ninth grade me is asking. You don't, here's the reason you don't want me to, that's a great question. And somehow I'll open up a portal for, oh, maybe, remind me, I'll open up a portal for great questions that I don't answer in class or something, maybe. That's such a great question that the reason I'm not going to answer it in class is because, oh, if you think I'm going to have a hard time getting back to the topic with this question that was asked, I will never get back to the topic if I start answering that. Like, I hear you. I hated them too. Like so many things, I hated graphs. I hated proofs. I hated, what else did I hate? I hated a lot. I hated all those things. Oh, I hated units. I hated scientific notation, like all of these things. Believe me, I hated proofs at a certain stage of my life. But sadly, now I love them. You don't want to get me started on this now. Like, I hear you if you don't like them, but ultimately, all there is, okay, here I go. Okay, you're going to be regret that you asked this. No, it's a great question, but like, look, the whole point is proof. I mean, on the one hand, there's no such thing really as a proof, like really. But derivation, things that come close to proofs, that's what we're here to do. What is a proof? A proof, here I go. Oh my God. All right, no, I'm gonna say this and then I'm gonna go on. And it's gonna be more therapy for me than for you. But what is a proof? A proof is the art of a proof is we start with something that we so deeply agree on that seems so obvious, like a definition or a really self-evident like observation, like a triangle is a triangle, or like an object can't be in two places at once or something like that. We start with something that seems so self-evident that not only could nobody disagree with it, but no one. Wait, okay, hang on, just wait. Give me a break for a second. Like this is gonna get on. Just 1 second with the chat. Here's my plea for proofs. Because honestly, and I got to tell you, in a way, once we get rolling, I don't know whether you're going to call them that or not. I don't know whether I'm calling them that. But in a way, everything we do in physics after a certain point is, in effect, a proof or at least a derivation. Why? Because the whole point of a derivation is you start with something that's so obvious, no one would ever think to disagree with it. And in fact, so obvious that most people wouldn't even think it's worth bringing up. And you show how by a series of unarguable, untestable, tiny little steps of logic, you can move from something completely self-evident and obvious to something completely surprising, unexpected, and maybe counterintuitive, such as black holes exist, or such as one twin can be older than another twin as long as he's blasted off or she's blasted off at a fast enough rate into outer space, or such as the Earth isn't the center of the universe, there is no center, or whatever, or the whole point of a proof is it shows that the inescapable logic of moving from something that's obvious that we already know and we don't even care about to something that is so unknown and so surprising that we can't help but care about it because we don't even want to accept it. That's what the point of a proof is. But of course, the smaller ones that you do in geometry, that in ninth grade or whatever, that all seem very uninteresting, are all practicing for that art. But what they're all, and so maybe you don't care about any of the content. Maybe the surprises at the end of the ninth grade proofs are like, oh, and so the two parallel lines are cut by a transversal. The alternate interior angles are congruent. That maybe that's the big surprise at the end of a proof, and you're like, well, great, when's lunch? Like, I really still don't care. I can relate to that. I understand that. But the art of practicing proofs is to get us set for the real proofs of scientific research, which are all about bringing us from things we did know to things that we didn't know, but in a manner that is unarguable. Like, that's what it's all about. I'm going to stop yelling now. But I'm going to look in the chat. Wait, but great question, really. Yeah, look, I know. Look, the thing about geometry, I'm entertaining this because I do love your questions and I do love this class. And yeah, who are we kidding? Like physics class is kind of physics class in a way is secret group therapy for those of us who have been damaged by math and are still looking for healing. I understand that. We're damaged not by math, but by math classes at some point. I understand that. And I'm that guy too, okay? All of this is just me healing like math moves from 5th grade. But I understand. So I'm going to entertain this a little bit more. I bet only a little bit more. I understand that even like Avani's being very nice, like saying like Cactus Ever, thank you. Yes, I like, and I kind of mean that too. But I like that Avani's saying like that, and I know I skipped some things. Wait, sorry. It's funny what Chris said about the functions, and I also know that when Chris makes those jokes, he's kind of half joking because he kind of likes math. Like I get, so I'm gonna move on from Chris's thing for a second. But Avani's thing, like really, I understand that too. Like that, I think the idea of proofs, but the proofs in geometry are like they're dry, they're super dry, they're super abstract, they're super about things that you would not think that you would care about. They have no human content. Geometry does not. Geometry is one of the purest mathematical branches there is, and math is the purest version of science. The purity of it is that it makes no reference to the human condition, right? Nothing in any geometry proof ever even slightly makes a reference to a feeling or a relationship or an experience or any, and I'm not being sarcastic, like I know that. Like, unlike, at least when you read history, or at least when you're in poli-sci or criminal justice, at least you're like talking about people and like what's right or wrong and feels good or feels bad. Like, I get that. That's all about life. And geometry seems like it has nothing to do with life, seems that way. But and I get that. It's totally abstract. And so is a lot of this physics, certainly the underpinning math. But let me tell you all, one of the reasons I like this stuff, it's not because I don't see that it's not about the human condition or about feelings, but it's because in part it is a safe haven from the complexity and mess of the human race and human feelings and human relations. All I can say for the moment, like I'm a human too. I live in the world too. But sometimes the world is hard and messy and gross and confusing to me. Okay, sometimes I like it, sometimes I don't. And something about math is sometimes I get math problems wrong for sure, but never do math problems wrong me. Never once has a math problem broken up with me or spilled a drink on me or hit me on the side with its car or whatever, or like voted. Never once has a math problem joined the wrong political party or like whatever you want to say. Like the thing about math, and you're getting me all excited. I'm going to stop. But the thing about math is to science as geometry is to math. The more pure you go down the line, the less it's talking about any given human being or any given human feeling. That means it's equally distant and equally applicable to all feelings and all human beings. The thing about math is that it's universal. It is the language that outer space speaks and thinks. It sort of seems distant from all of us, but it's equally distant from all of us. It's literally, therefore, equally accessible to all of us. Math is pure thought. It is an escape from messy, specialized, prejudiced, biased, and bullying emotions. That's what I got to say about it, okay? Like I hated it too when I hated it. But when I love it, it loves me back in a way that poli-sci cannot, and government cannot, and blah, blah, blah cannot. It just is what it is. And when I am relating to it, it is relating to me in exactly the way that it's meant to. It is the language of the universe. That's all I got to say about that for the moment. But all right, I'm going to look at the chat. Okay. All right. Fair enough. You guys can have the last word. Yes, it can give you nightmares and it can hurt the brain cells. I don't think it can hurt the heart, but it can hurt. It doesn't really hurt the brain cells. It hurts the ego. But okay, whatever. But yes, okay, we're going to move on. These are great questions. I obviously do like this discussion. And but now the person who in the original private chat asked for the triple equal sign, the double equal sign, he or she is like, okay, I'm never doing that again. But no, I hope that's not the inference that he or she came to. And maybe he or she who asked about the triple equal sign could tell me if at least I answered her or his question. But now I'm going to go on. Okay. There we go. I love it. And you get points for that. Okay, cool. Okay. So now, you know what? Okay, this is a serious thing now. As long as, here's what's funny. This is a serious thing, and we will go back. And if I don't finish the whole thing, you can obviously watch the other class video, but I will. We aren't finishing the whole sheet today anyway. We're finishing on Wednesday anyway. But here's a serious thing, actually. It's funny that one person asked about triple equal sign and double equal sign, and then somehow I forget how, like that led to other people talking about geometry and proofs and stuff. One thing is this. The real deal is this. Triple equal signs are, might as well. I went off on the cold there. It's actually worth it for me to seriously summarize the conclusion of this. Something that I used to talk a lot about in class. Actually, let me just say this: with triple equal signs. Now, note this: triple equal signs, which are the most prominent in geometry. Like whoever of you brought up that example, like geometry is like full of triple equal signs, like things that, yeah, like, oh, well, I guess because we were using the square and the triangle example. So okay, so the advantage of triple equal signs is that really they're 100% reliable. They, like, if they're any triple equal sign that's true is true always. They're totally absolute. They're totally rigid. Totally reliable. That's the good news. They're like math to the extreme. Triple equal signs are. The disadvantage is exactly that. Exactly what some of you were like jokingly or not jokingly complaining about math, and we all know it. That math is ultimately circular. It is. I know that too. Like, in other words, like, even those proofs that ultimately prove things like alternate interior angles are congruent, like part of the reason that they leave you cold and you like they're annoying is because at the end of the day, they're only saying something about, like, their conclusion. They start with a geometry assumption and they end with a geometry conclusion. And they're ultimately just saying something. They're just moving words around and numbers around the page to say something that they're, if the proof is really right, it's really just saying something that it's claiming we always knew from the start. We just didn't know we knew. That's why they can expect us to do proofs, right? If they're really that logical, then in theory, the conclusion we knew all along the minute we wrote down the beginning, we just didn't know that we knew it, right? So in a way, the reason that those proofs leave everybody cold is because they just go around and, it's like proving that a square must be a rectangle. Like, that's true because of the way the words work and everything, but who cares if at the end of the day you haven't said anything about anything other than the words square and rectangle? So the advantage of triple equal signs is that they're totally reliable, but the disadvantage is they don't say anything about empirical data in space and time or the world. They don't actually point outside. So, right? But flip side, and I'll finish this as long as we're doing this. Flip side, double equal signs, the advantage that they do reference to the empirical data from space time. In other words, double signs are actually relevant. We actually care about them. And I mean, me too. Like, right? Example, right? Like, it's like PV equals nRT. That's not a triple equal sign. That was like a discovery. And like, we do all these things with PV, like we make engines out of PV equals nRT. Like, it's like relevant to the world, right? But the disadvantage, approximate, they're conditional, approximate, non-rigid, not reliable. Like PV equals nRT is only sort of true and only sort of true under certain conditions and only certain contexts. It's like a very limited truth. And we discovered it in the lab under certain conditions. So someday, if our labs are better and we have different, we might like discover that it's not as true as we thought, right? Not fully. The advantage of triple equal signs is rigidity. The disadvantage is irrelevance. The advantage of double equal signs is relevance. The disadvantage is unreliability. The point is, you may not accept this or agree with this, but in my judgment, the point of physics physics, we distinguish between double equal signs and triple equal signs so that we can keep them both running together in harmony. Physics is meant to be somewhere between pure math, pure prescriptive but non-descriptive math, and pure, say, descriptive but not prescriptive biology or something. I'm not making a judgment call. I'm not making favorites or something. Like, we all have our what we like. But the point of physics is that it's constantly running double equal signs and triple equal signs next to each other, so that actually we try to get some kind of relevant statement about the world out of analysis that is mathematical and that we find super reliable and rigid. The art of physics is applying the rigidity of math to the relevance of the world, applying the strength of triple equal signs to the appeal of double equal signs. And part of the way we do that is we make that distinction from the get-go. We actually notice, wait, there's two types of things going on here. They're both valuable, but let's deal with them both and let's keep them like labeled as we go. That's the deal of physics. Like, that's why I like physics, is it tries to apply the rigidity and reliability of math to the actual relevance of the world. Like, that's what we're trying to do. For good or for bad, doesn't work for everybody, obviously. But I am glad that someone asked a question. That's my like little serious. If that puts anything in perspective for you, great. If not, we're going to go on. Oh, I'm going to say before I lose everything, we're going to go on. And again, I was never, I will get back to the topic. We were never going to finish a homework for today. You still are not getting new homework until we do. So don't worry about that. But I will go back to wherever we were. We were here. But great question, seriously. And I hope, well, I hope you don't regret that you asked those questions, because I don't. And we will still cover the material no matter what, I promise. Also, you'll only be tested on what we do. I promise that too. So here's the equation, the definition of average acceleration. It is change in velocity per time. So I'm just going to apply it to these facts of problem 3. Here we go. Obviously, this is a whole interlude here. We apply it to those facts. I'm just plugging in. 60 was the final instantaneous velocity. 0 miles per hour was the initial instantaneous velocity. We divide by 2 minutes. I'm just, oh my God. And this class ends in 3. Oh, I'm glad I just checked. Wow. Okay, I am aware that this class ends in, I didn't think we were that close to time, but okay. Okay. Say, as a compromise too, where I'm going to say, we're going to end in 3 minutes. I'm not going to keep you late. Obviously, I didn't get to every. Well, we're close. All right, we're actually close. Here we go. So we are close. Okay. Question B. So question A, we get 30 miles per hour per minute. I'm going to be quick. I'm going to upload these notes, of course, and you can read the fine print of the notes. But the bottom line is, look at that is correct. Is that standard MKS? Proper science units? No, it's not standard, but it's totally legitimate units. It's miles per hour per minute. And it's written that way to emphasize, like, you may be used to seeing accelerations written other ways, as you will in a moment in the next question. But there, I just want to emphasize, there's no rule that says the two types of time units have to match. That's not a rule. It's just that there do have to be two references to time. Acceleration is change in velocity. Velocity is change in position per time. So an acceleration is how many miles per hour you advance or change by every, in this case, minute, right? This means after 3 minutes, this car will be going 90 miles per hour. It does not mean that after 3 minutes, it will have traveled 90 miles. That's a totally different question, which we get to next, and a totally different answer. What it means is every minute, it's advancing its velocity by 30 miles per hour. Okay, that's question 8. Not standard units, but legitimate units. But then if we want to sort of change them into slightly more legitimate units, we could do the unit conversions. It's harder for some people than for others. We could discuss it in more detail next time if you wish. But I did the unit conversion sort of my way, and I ended up dividing by 60 by 60 by 60 again to get all of those hours and minutes all down converted to seconds. So then in the end, I have this really, really tiny number that is in miles per second squared. Sure, we generally do meters per second squared. Sure, fine. But here it happens to be miles. But notice, bottom line, miles per second squared sounds like we're squaring time or we're doing some weird thing like that. We're just really saying miles per second. It's just like saying miles per hour per minute. We're saying miles per second, and then just shorthanding it with a square. So that's the answer written in more standard units. And then for the next two, oh yeah, okay. Here, and I did this in the other class too. We're actually caught up to the other class. this is as far as I got in the other class. The next problem 4, I just literally am writing down I'm just literally writing down the answer. So you can check if you did it right as well. I didn't, and I know it's 425. So just look, and I'm going to post this PDF anyway. But in the end of the day, the answers I get for the accelerations are +4, -4, -4, and +4. So, and the summary of, I know I'm going fast right now. We're done. But that question with the Audi and the Buick and the dirt bike and what's the summary of the whole thing? The summary is to accelerate positively could mean to speed up while you're moving in a positive direction, but could also mean to slow down while you're moving in a negative direction. And vice versa with negative acceleration. Like acceleration means change in velocity. To accelerate positively just means for your velocity numbers to get bigger. If they're positive numbers, that means you're going faster. If they're negative numbers, when negative numbers get bigger, they get closer to 0. So you're going slower. So you have to recognize that. If that's too much, think about it or play the video again or ask me questions next time. But you do have to see that that is a point. That's as far as I got in the other class too. We're actually all on. So great discussion. I don't know how we all pulled that off, but we did. You're a great class. I'm done. I'll stay and answer any questions anybody might have. But other than that, I'll see you Wednesday. There's no new homework. Just catch up as I will. And I'm turning off the recording.
Gracias.
Sorry, what? Oh, okay, I'm turning off the recording. Okay, great.